So a really important thing to remember about right triangles is that the hypotenuse, okay, the side that connects the legs, it's always going to be the longest side of a right triangle. Okay, so basically the denominator of a sine or cosine ratio is always greater than the numerator. Okay. Again, if you're dividing by the hypotenuse, that's kind of what's going to end up happening there. So it says, therefore, the sine and the cosine of an acute angle are always positive numbers less than 1. So I'm going to underline this. It's very important. Okay. Therefore, the sine and the cosine of an acute angle are always positive numbers less than 1. Okay. It now says, since the tangent of an acute angle is the ratio of the lengths of the legs, it can have any value greater than 0. So you may have noticed already that you know, some of the tangent ratios that we've gotten, well, the tangent's actually greater than 1. Okay, whereas if we're finding the sine or the cosine of an acute angle, it's always between 0 and 1. So it's just kind of something to note. Okay, so let's look at a few examples of how we can use trig ratios to find lengths of right triangles given, you know, a side length and maybe a degree, or the measure of one of the acute angles. So it says find the length round to the nearest hundredth. Okay, so we are looking for the length of BC. Okay, so this is what we're actually trying to figure out. Now, let's think about what we actually know here. Okay, we know this angle B right here. Okay, we know that that's 15 degrees. Okay, they give us the opposite side. Okay, they give us that length, and we want to know the adjacent side. Okay, so when we look back up at, I'm just going to write SOHCAHTOA. When we look at SOHCAHTOA, which one gives us the opposite side and the adjacent side? Well, opposite and adjacent is right here, so it looks like we're actually going to write tangent. All right, so what we would do in this case is we're just going to write this. The tangent of 15 degrees is going to be equal to, and I'm going to write, for right now, I'll just write opposite over adjacent. Okay, now the tangent of 15 degrees is going to be equal, well, that opposite side of AC is 10.2 feet. Okay, and the adjacent side, again, the one that's connected to B, is BC. So I'm just going to write this as BC. All right, and now we have to, you know, use inverse operations, or you know, we could use the cross products property, I guess, if we wanted to find this unknown length. But what I'm going to do next in this next term here is I'm going to multiply both sides by BC. Okay, and when I multiply both sides by BC, these will cross reduce, and what I'm going to end up with now is BC times the tangent of 15 degrees equals 10.2. Okay, so that's all fine and dandy, but I still don't have BC isolated. Okay, so the next thing I'm going to do is I'm going to divide both sides by the tangent of 15 degrees. Okay, and so I'm going to have to come up here to finish this problem. Okay, so at this point, you know, we'll have BC isolated, and so we're going to say BC is going to be equal to 10.2 over the tangent of 15 degrees. Okay, now here's how we're going to type this into this really basic calculator with the trig functions here. Okay, so all I'm going to type in is, I'm going to type in 10.2. I'm just going to write this as one button, 10.2. We're going to write, you know, the division sign is next. Okay, so again, 10.2 divided by, and I'm going to write, then I'm going to go 15, and then I'm going to type the tangent button, and then I'll type equals. So again, 10.2 divided by 15 tangent equals 38.07, we'll call it. So I'm going to say BC equals 38.07. Okay, now again, look at your picture, look what you actually got, ask yourself, okay, is this actually realistic? And yes, I would say that's a realistic answer. Okay, if you got something like, you know, a negative number or for whatever reason, or you got like a really big number, obviously check your work and make sure that you did it properly. Okay, let's look at a couple more examples here. Okay, this is just a quick warning that tells us to make sure we don't round until the very final step. Okay, otherwise we'll get a bad answer. All right, so let's look at another one. Okay, so this time we're looking for QR. Okay, we want to know the length of QR. They give us a couple important pieces of information here. Okay, they tell us that angle P here is 63 degrees. Okay, that's definitely an important piece of information. It looks like they give us the hypotenuse. Okay, and they want us to find the opposite side. Okay, it's the opposite and the hypotenuse. Okay, so if we look at again, if we look at SOHCAHTOA. Okay, if we look at SOHCAHTOA here, again, we were given the opposite side of P, of angle P, and we were given the hypotenuse. So opposite and hypotenuse to me is right here. So I'm going to use the sine ratio. Okay, so I'm going to say that the sine of 63 degrees equals the opposite over the opposite leg over the hypotenuse. Okay, well, the sine of 63 degrees is going to be equal to, well, QR is what we don't know, so I'm just going to write it as QR over the hypotenuse, which we do know is 12.9. Okay, now this one's a little bit easier. I can just multiply both sides here by 12.9, and I will get my final answer. Okay, now when I'm using this sort of cheaper calculator, what I like to do is find the sine of 63 degrees first. So I'm actually going to type in 63, then I'll press the sine, and it gives me, you know, about 0.89. I'm not going to round yet. I'm just going to multiply. So press the times button and multiply by 12.9, and I get my answer of 11.49. Okay, so I'm going to say the sine of 63 degrees. Actually, I'm not going to write that. Sorry about that. I'm going to say that QR equals 11.49. Okay, and we can look at that. You see how it's just a little bit less than the hypotenuse? Remember, the hypotenuse is always going to be the longest, so that seems like a pretty feasible answer. Okay, and let's go ahead and just look at one more example here. Okay, so example 1C, this time we're looking for FD. Okay, so we're looking for FD. Remember, we know that angle F is 39 degrees. Okay, we know the adjacent side, and we want to know the hypotenuse. Okay, so if we look again at SOHCAHTOA. Okay, again, we're given the adjacent side and the hypotenuse. So looks right here that like cosine would be the one to use. So we're going to say that the cosine of 39 degrees is going to be equal to the adjacent over the hypotenuse. The cosine of 39 degrees is going to be equal to the adjacent side is, again, connected to the vertex, so that's 20. The hypotenuse here is FD, that's what they want, okay? And now we're just going to go ahead and sort of move things around using the inverse operations to find our answer. So I'll multiply both sides by FD to start. Okay, and again, we can also use the cross products property here as a reminder. It's basically what we're doing anyways. Okay, so now I have FD times the cosine of 39 degrees, and that is equal to 20. Okay, now remember, I actually have to divide both sides by the cosine of 39 degrees. Okay, now this will cause some things to cancel here and divide to 1. So now basically I have that FD is going to be equal to 20 divided by the cosine of 39 degrees. Okay, and when I type this into my calculator, and I should probably include units, which I did not on the last one, but our units are meters here. Okay, and so I'm going to take 20 and then press the division sign, and I will put now 39 and then type the cosine number, or the cosine button, and then press the equal sign, and I get 25.74, about 25.74 meters. Okay, and that is FD. Now again, that's the hypotenuse. It's a little bit longer than one of the legs there. So again, that seems like a pretty feasible answer.